Okay, so we're going to continue with quadratic equations. And the problem is that sometimes factoring doesn't work. And so we need to figure out other ways to handle quadratic equations. So here's a quadratic equation. What do we need to solve this? Two numbers that multiply to give 11, right? So the only options are 11 times 1. 11 is a prime number. So we get 11 and we get 1. Those are the only whole numbers that work. There are other numbers that work that we'll see, but they're not nice integers. But these only, if you only have 11 and 1 to work with, what are the things you can get by adding and subtracting? Well, minus 12, minus 10, 10, and 12. Right? So for example, minus 11 minus 1, that's minus 12. So you can't get 8. That doesn't factor. So how can we solve this if we can't factor it? Well, we can look at the quadratic formula, which is a way to solve quadratic equations that can't be factored. We'll see where this formula comes from when we do completing the square in Chapter 2. But if, what is the quadratic formula? Ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And note, a can't be 0, but of course if a is 0, right, you don't actually have a quadratic because you wouldn't have an x squared term. You just have a bx plus c, and that's actually pretty easy to solve. So a is, pretty much never 0. Great, so it's just a formula. If you can identify the coefficients a, b, c of the quadratic equation you're trying to solve, plug them in, and that'll tell you what your x's is. And note that most of the time you'll get two answers, a plus and a minus. So for example, if we go back to our x squared plus 8x plus 11, remember that if you see an x squared all by itself, that's a 1 times it. So a equals 1, b equals 8, c equals 11, and then we just plug it in and simplify and see what we get. So negative b would be negative 8 plus or minus the square root of b squared, so that's 8 squared, minus 4 times 1 times 11 all over 2 times 1. Right, so there's my negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And now we simplify. So what we'll do is we'll leave everything alone in the bottom and deal with this square root here first. So minus 8 plus or minus, well, 8 squared is 64. 4 times 1 times 11 is 44. And that's all over 2. We'll actually multiply the 2 times the 1 in the bottom. Negative 8 plus or minus square root of 20 all over 2. And now we can simplify this a little bit because 20 is equal to 4 times 5, which is 2 squared times 5. And so square root of 20, right, as we saw when we were doing powers, is 20 to the 1/2. So that's 2 squared times 5, quantity to the 1/2, and we know how to simplify that. Distribute the 1/2 to both of these things. 2 times 1/2, that's just 1. 5 to the 1/2 is the square root of 5. So square root of 20 is actually equal to 2 times the square root of 5, right? And so what you see is if you have a square root of a number and it's got a square factor in it, you can factor out the number part, right? So the 2 can come out. So this is 8x equals minus 8 plus or minus 2 square root of 5 over 2. And how can we simplify that? Well, right off the bat we can't simplify because there's a plus or minus. And you can only simplify if things are multiplied together. You can only cancel in a fraction if things are multiplied together. But we can factor 2 out of the top. And then we have a 2 on the bottom. And now this 2 and this 2 can cancel out. And there's our solution. Minus 4 plus or minus square root of 5. And again, 2 solutions because there's a plus or minus. So my roots are x equals minus 4 plus square root of 5, or x equals minus 4 minus square root of 5. Those are my two possible roots. What are my factors? Right? What was the equation we're dealing with was x squared plus 8x plus 11. And we said we can't factor it, and that was sort of true and sort of not, right? We can't factor it using whole numbers. But now that we know the roots, right? X equals minus 4 plus square root of 5. If I set this equal, if I get a 0 on one side, what is this? Well, add a 4 minus square root of 5 equal to 0. The other root, minus 4 minus square root of 5. Get 0 on one side, so x plus 4 plus square root of 5 equals 0. And so what do we actually have? Here is one factor, and here's another factor. So we can't actually factor this thing. X squared plus 8x plus 11 equals x plus 4 minus root 5 x plus 4 plus root 5. And if you multiply that out by if you multiply out this right side by distribution, you'll get the left side, x squared plus 8x plus 11. So if you know the roots, you can get the factors back, and so you can factor even things like this. This doesn't factor nicely, this thing here doesn't factor nicely over integers, unfortunately. You have to use the quadratic equation to get the factors. And usually when you're trying to solve the quadratic equation, you're interested in what the roots are and not the factors. Okay, so note that there's a square root involved in the quadratic equation. Sometimes you only get one solution. So x squared plus 4x plus 4 equals 0. This can actually factor into x plus 2 times x plus 2 equals 0, or x plus 2 quantity squared equals 0. There's only one possible solution to that, right? X equals minus 2. That's the only way you can get x plus 2 squared equals 0. If we do this quadratic equation, right, we should get the same result, x equals minus 2, only one solution. But what happens to the plus or minus? Right? The quadratic equation has got that plus or minus. So here a equals 1, b equals 4, c equals 4. That's a 1 times that. Sorry about that. So x is negative b plus or minus the square root of b squared, which in this case is 16, minus 4ac. So 4 times 1 times 4, that's another 16, all over 2a, so it's 2 times 1. And what happens in this case is I get 0 inside the square root, because we get b squared minus 4ac actually equals 0. And so there's only one possibility, because plus or minus 0 doesn't really matter. You get minus 4 over 2, which is minus 2. So sometimes in using quadratic equations, solving quadratic equations, we get only one solution, and that means either, if you look at it from a factoring point of view, you get something like this, x plus 2 squared equals 0, or if you're using a quadratic equation, you get 0 inside the square root. One other option that happens with a quadratic equation is no solutions. So if we take x squared plus x plus 7, so a equals 1, b equals 1, c equals 7, and the equation is, what is x there? Well, remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The question is, what happens if this thing, right, the thing inside the square root, what happens if that's negative? Because you can't take the square root of a negative number. So negative 1 plus or minus 1 minus 4 times a times c, that'll be 28 all over 2, and of course this example gives us a negative inside the square root. all over 2. So what do you do with that? Well, there is a way to handle that, actually. There's something called complex numbers, which you may or may not seen, right? I square root of minus 1. But in this class, we're not going to deal with complex numbers, so we don't have to worry about this. So we just say no solution, because we're not looking for complex numbers. Okay, so the quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, a little thing that has to be memorized. Very useful in handling quadratic equations that can't be factored. And remember, you get 2 solutions. Sometimes you get 1 solution, sometimes you get no solutions, right? But the plus or minus in the square root is what gets you the 2 solutions. The third way to handle quadratic equations is completing the square, and we will see that in Chapter 2. So we will end the appendices here and move to Chapter 1, which is about lines and inequalities and